Welcome everyone to today's explainer. Let's get right into it. Having a single AI agent do a neat little trick, that's a cute demo, but trying to actually orchestrate 5 agents to run a complex real-world workflow without the whole system just completely crashing, yeah, that is an absolute nightmare. Okay, let's dive into this, because across the industry right now, we're seeing this very predictable cycle. Product teams realize their single AI agent is getting super bogged down with these massive bloated prompts, and eventually it just starts hallucinating. So the natural reaction is, hey, let's build a multi-agent system. Let's spin up a whole team of specialized bots to work together. But doing this blindly, it brings some brutal new challenges right to your doorstep. You literally immediately hit what we call the coordination collapse. And this is a critical realization. The exact moment you move from one agent to a team of them, your primary challenge shifts entirely. It's no longer about the quality of the individual models, it's all about system-wide coordination. You've got to understand that as a builder, you are no longer just shipping a clever AI feature. You're managing a totally virtual workspace where these probabilistic models actually have to plan, act, and hand off work to each other under strict, real-world constraints. And if you don't have an explicitly designed orchestration layer to manage all those handoffs, your beautiful state-of-the-art AI product collapses into what we call the messy middle. Suddenly, you've got agents literally talking over each other. They're duplicating work, overwriting each other's code, and getting stuck in these endless, super frustrating debate loops. It is, frankly, pure operational chaos. So listen to this harsh reality check. Throwing more agents at a problem isn't just some free upgrade you get because the tech is cool. Setting up these systems can easily multiply your compute costs by 15 times. 15 times, just to have these bots sit there and talk to each other. And this brilliantly illustrates the staggering financial impact of that. For a standard customer support workflow, you go from a single agent support model, which costs maybe around 10 cents an interaction, jumping all the way up to $1.50 when it's handed over to a multi-agent system. That is a massive, massive spike for a single execution. And if you scale that up without a solid plan, it will absolutely destroy your margins. But, cost isn't even the only issue here. It gets way worse. Multi-agent systems absolutely massacre latency. Let's think about how this breaks down. Every single time one agent hands off a task to another, you get hit with a new context switch and a brand new model call. That's a latency penalty of anywhere between 100 and 500 milliseconds per handoff. So if you chain 5 agents together to answer a simple user query, you are adding over 2 seconds of pure delay. In a world where your users expect sub-second responsiveness, a 2-second thinking pause, that's a product killer. It will absolutely tank your adoption. And then, oh boy, we arrive at the debugging nightmare, the dreaded argument loops. Just imagine a scenario where a verification agent silently rejects a perfectly valid answer from your planner agent, and it forces the whole system into an endless, invisible debate. Diagnosing a bug across 5 independent agents is exponentially harder than tweaking a single text prompt. Basically, if you aren't heavily tracking and logging every single handoff, you are flying completely blind in production. Honestly, it's actually kind of funny if you think about it in human terms. If you put 5 hyper-intelligent, hyper-confident specialists into a conference room without a manager and tell them to build a product, they are going to ship absolutely nothing. They'll just argue. The exact same rule applies to your AI. You don't need more raw intelligence. You need a boss to manage all these AI specialists.
Section 1. Proven orchestration patterns. How to stop winging it.
So, how do we fix this? Well, there's no single perfect pattern for everyone. The best pattern is simply the one that fits your specific product, your risk profile, and frankly, your user's patience. But here is the standard playbook. We generally see 3 main patterns: tool routing, the planner-executor loop, and guardrails with verification. Let's break these down so you know exactly when to use them. Now, what's really interesting about this slide is the concept of tool routing. This is dynamic selection right at runtime. Instead of defaulting to a massive, slow, multi-agent chain for every single query, the system analyzes the user's request first. It sends the routine, predictable tasks straight over to a fast, cheap API, and then only routes the complex, nuanced problems to a heavy reasoning model. This right here is your fastest path to success and the absolute quickest win for controlling both your latency and your API costs. Next up is the planner-executor loop. Think about how a human team works. If a human project manager would naturally break down a messy, multi-step workflow into distinct phases, your AI system should do exactly the same thing. This pattern explicitly splits reasoning away from action. You have a planner agent that looks at the overall goal and writes out a step-by-step blueprint. Then, specialized executor agents carry out those individual steps and report back. It just keeps everything incredibly organized. And finally, we have verification loops. This is essentially a firewall. An independent verifier agent actively checks a drafting agent's work for safety, compliance, and any hallucinations. I literally cannot stress this enough. If your agents have the ability to take real-world actions, like writing to a production database or automatically emailing your clients, this verification firewall is an absolute, non-negotiable requirement before the user ever sees the thing. Let's look at a quick, punchy contrast of how this actually plays out in the real world. On the left, you have your naive, reactive PM. They're bragging, oh, our new AI agent does everything. It researches, it codes, it pushes to GitHub entirely autonomously. And boom, they just wiped the production database because they trusted a raw hallucination. But on the right, you have the lethal PM. They orchestrated a strict supervisor and verification loop. The coding agent drafts the work, a separate security agent runs an analysis, and even if it passes, it waits for human-in-the-loop approval. That right there is the product manager who actually gets promoted. Let's move to Section 2 and see how this builds. The Enterprise Execution Playbook, Scaling Orchestration. Take Walmart, for example. Tim Simmons, their CPO of International, talks about a future where they manage entire fleets of AI agents, not just single models. By orchestrating specialized agents, so routing, checking, and improving across a workflow, they managed to turn a massive 30-week product translation and localization process into just 8 weeks. When you orchestrate these agents correctly, your massive corporate complexity actually transforms into a huge competitive advantage. And here is another really fantastic example. Karen Singh, SVP of Product at HubSpot, points out that while customer agents can resolve 40 to 50% of issues autonomously, the humans stay firmly in the loop. So the crucial point to take away here is that these highly successful enterprise systems, they do not remove human workers. They supercharge them. They handle the messy middle, so the humans can just focus on the final sign-off. So if you are building one of these systems, here is your tactical job description as the orchestrator. First, you must explicitly design the handoffs between agents. You need to clearly define exactly what the orchestrator can safely auto-approve. You've got to know when to escalate a complex issue to a human. And above all else, you have to instrument the entire system, logging exactly where your agents slow down, where they get stuck in loops, and where they trigger your safety guardrails. Section 3, Designing Resilient AI Workflows, the final reality check. I really want you to ask yourself honestly, are you starting with a modular, scalable architecture from day one? Or are you currently building a super brittle multi-agent masterpiece that nobody actually trusts, no engineer can possibly debug, and your finance team definitely isn't going to pay the API bills for? The messy middle we've explored today is exactly where fragile prototypes go to die. So let's synthesize everything we've talked about into one crystal clear formula. Specialized agents plus defined routing plus verification loops equals scalable orchestration. You have to match your specific orchestration pattern to the complexity of the task at hand. You absolutely have to design your costs and your latency budgets before you attempt to scale. Please, whatever you do, don't just wing it. Now that you know how to build a robust, agentic workflow, I'd love to hear about the learning curves you've all experienced. So tell me, what is the most expensive, chaotic AI loop you have ever accidentally triggered while building? Keep building safely, and I'll catch you on the next explainer.